Hey Chemistry, Mrs. KJ here, going over 2.04, Review the Atom. Review concepts presented in the lessons, early theories of the atom, the nuclear atom, and atomic number and mass number. Many scientists worked over several centuries to discover the structure of the atom, the arrangement of subatomic particles, and the properties that make atoms unique. The atomic number of an atom, which is the number of protons in its nucleus, is what makes the atoms of one element different from those of another element. Remember, you can gain, lose, or share what? Electrons. And different atoms of the same element can have different numbers of neutrons as well, which affects what number? The mass number. All right. So I am not going to be taking notes on this one since it's a review, but please feel free to take notes on what you need to. Key concepts and early theories of the atom. So the atomic model was developed primarily by Democritus, Dalton, J.J. Thomson's cathode ray tube, and Millikan's oil can drop experiment. Early Greek philosopher Democritus believed that matter was made up of indivisible particles. John Dalton developed the first modern atomic theory of matter. J.J. Thomson discovered that electrons were negatively charged particles. Robert Millikan's experiments determined the charge and the mass of electrons in the atom. Early concepts in the nuclear atom. So atom's atomic model was developed further by Rutherford's gold foil experiment. The atom's particles outside the nucleus can be found the electrons, part of the nucleus made up of protons and neutrons. So if I ask you what is in the nucleus, you would say protons and neutrons. Ernest Rutherford's gold foil experiment suggested that the atom had a small, dense, positively charged center surrounded by negative charges. Later experiments showed that there are positive and neutral particles within the nucleus called protons and neutrons. Protons have a charge of +1, electrons have a charge of -1, and neutrons have no charge. Protons and neutrons have roughly the same mass, which we call 1 AMU, or 1 atomic mass unit. Electrons are much less massive than protons and neutrons, so we ignore them when we're doing the mass of the atom. Key concepts in atomic number and mass number. So atom characteristics, the atomic number is the number of protons. This determines which element you have. The mass number is the sum of the number of protons plus the number of neutrons. The atomic number of an atom is equal to the number of protons in the nucleus and is what gives an atom its identity. The mass number of an atom is equal to the number of protons plus the number of neutrons in that atom. In an electrically neutral atom, the number of protons is the same as the number of electrons. All right. So, atoms discovered by scientists through experiments such as gold foil and what else? Hit pause, get your answer. Millikan's oil can drop. Atoms are divided into the nucleus and something else. All right, so hit pause. What's your answer? The electrons, because they're outside the nucleus. Inside the nucleus is protons and what? Hit pause. Neutrons. The number of protons is the what? Hit pause. Atomic number. And the protons plus the neutrons added together equals, obviously, the mass number. Woohoo! All right. So we are going to go through the problem set as well. There's a quiz. And if you do look at this, let me know if you think it's good and I should talk about it in class or add it to the other links that I have for you. All right, let's go over problem set 11, early theories of the atom. Objectives, describe the historical development of the concept of the atom. Describe the contributions of early scientists to the modern theory of the atom. I will tell you the only scientist they're going to ask you about in the quiz for this section is Dalton. So make sure you know what Dalton thought. Modern atomic theory is based on the work of many different scientists. For thousands of years, scientists have sought to understand matter and the tiny particles that matter is made of. During that time, many different models of the atom have been proposed, tested, and rejected. One of the first people to propose a model of the atom was Democritus, a Greek philosopher. According to Democritus, atoms were indivisible. That is, the atom was the absolute smallest particle of matter possible. Obviously, we know that that's false because we know that they're made of protons, electrons, and neutrons. In fact, the word atom is based on the Greek words atomos, which means indivisible. Since Democritus' time, scientists have learned a great deal about atoms and structure of matter. John Dalton, Robert Millikan, and J.J. Thomson were three scientists who contributed greatly to our current theory of the atom. All right, so big difference here. Dalton versus J.J. Thomson. So J.J. Thomson, remember, said it looked like plum pudding. And so these were the little raisins in the pudding. And it was a whole big mess of positively charged matter with some negative pieces in between. Dalton, on the other hand, thought the atoms were just a sphere. So the same all the way throughout. All right. Early atomic models. According to Democritus, all matter was made up of atoms which were indivisible. Democritus' ideas were not based on scientific experiments or observations because, well, they didn't have the technology. John Dalton's atomic theory was based on experimentation and observation. As a result, more scientists accepted it than accepted Democritus' ideas. J.J. Thomson's experiment with cathode ray tubes demonstrated that atoms contain smaller, negatively charged particles called electrons. Robert Millikan's oil can drop experiment allowed him and other scientists to calculate the amount of electric charge an electron carries. All right, so the big difference, besides what I already told you about Dalton and Thomson, both models assume that the atom as a whole has no net electric charge. So overall, it's neutral. And that an atom of an element has all the chemical properties of that element. However, Dalton's model assumes that the atom cannot be broken down into smaller pieces. Thomson's model assumes that the atoms are themselves made of smaller parts, such as the positively charged pudding and the negatively charged raisins. And of course, the pudding and raisins are comparing it to what he called the plum pudding model. Let's read the tip. Thomson's model of the atom is sometimes called the plum pudding model because of the way the electrons are scattered throughout the positively charged matter in the atom. A plum pudding is an English dessert that contains raisins scattered throughout a bready dough, rather like chocolate chips in a chocolate chip muffin. Tip. The other three parts of Dalton's atomic theory are still accepted as correct today, although they have been refined somewhat by the works of other scientists. So, what aspect of Dalton's atomic theory did Thomson disprove? Dalton's atomic theory states the following. All elements are made of atoms, which cannot be divided or broken down. All atoms of a given element are identical. Atoms of different elements are different. Atoms can be mixed together without reacting with one another. Atoms can also be combined chemically to form compounds. During a chemical reaction, the atoms and substances are rearranged. Chemical reactions cannot change an atom of one element into an atom of another element, so you can't take silver and turn it into gold. Thomson's cathode ray tube experiment showed that atoms contain smaller particles that are negatively charged. All right. So, a little bit of review. How did Robert Millikan contribute to our understanding of the atoms? Hit pause, get your answer. Answer is, Robert Millikan's oil drop experiments allowed scientists to calculate the charge and then the mass of the electron. Knowing the charge and mass of the electron allowed scientists to determine the amount of positive charge in an atom and to begin to understand the structure of atoms. Question 2. Describe the similarities and differences between Democritus' ideas about atoms and Dalton's atomic theory. Hit pause, get your answer. Answer is, both Dalton and Democritus envisioned atoms as tiny, indivisible particles. They both thought that the atoms were the smallest unit of matter. However, Dalton's atomic theory also explained how atoms react to form compounds, and it related elements and atoms to one another in a way that Democritus' ideas didn't. And question 3. Part of Dalton's atomic theory states that when atoms combine to form compounds, they always combine in the same whole number ratio for a given compound. Explain what that statement means. So hit pause, get your answer. The statement means that atoms of the same elements always combine in the same way to form particles of a given compound. For example, 2 atoms of oxygen and 1 atom of carbon combine in the same way all the time to form each particle of carbon dioxide. So basically he's saying carbon dioxide is always 1 carbon with 2 oxygens. Water is always what formula? H2O. Table salt is always what? Sodium chloride, which is NaCl. That's all that it means. Alright, next problem set, the nuclear atom. Objective, describe the composition of the nucleus of the atom. The modern scientific model of the atom consists of a central, positively charged nucleus surrounded by negatively charged electrons. Now, remember we talked about that the whole atom starts out neutral. So if I have 8 protons, how many electrons do I have? 8, because 8 positives and 8 negatives equals 0. But if we just look at the nucleus, all that is in the nucleus are the protons and neutrons. Neutrons are neutral, the protons are positive, so the nucleus is always positive because the negative electrons are zipping around the outside. Thomson's cathode ray tube experiment showed that atoms contain electrons. Thomson thought that the positively charged material in an atom made up most of the volume of the atom and that the electrons were embedded in this positively charged material. Ernest Rutherford's gold foil experiment showed that the positive charge in an atom is concentrated in a tiny region at its center called the nucleus. So it wasn't spread out all over like a cup of pudding. The nucleus is just in the center, really tight together. We now know that the nucleus is the center of the atom and contains protons and neutrons. Electrons orbit the nucleus at specific energy levels called orbitals, or shells, or energy levels, or the electron cloud. But again, orbitals is the best one to remember right now. Remember the nuclear atom. After Ernest Rutherford completed his gold foil experiments, he hypothesized that the positive charge in the nucleus is carried by individual particles, in the same way that the negative charge is carried by individual particles called electrons. Later, he proved the existence of these positively charged particles, which he called protons. Rutherford also hypothesized that there are neutral, uncharged particles in the nucleus. Later, another scientist, James Chadwick, proved the existence of these particles, which he called neutrons. Protons and neutrons have about the same mass. They are approximately 1,800 times more massive than an electron, which is why we ignore the mass of an electron when we find the mass of an atom. Protons and electrons have the same magnitude of electric charge, but protons carry a positive 1 charge, electrons carry a negative 1 charge. So in other words, they're equal but opposite charges. Atoms are electronically neutral, so they have the same number of protons and the same number of electrons. That can change, but when we start, the number of protons equals the number of electrons. Draw and label an illustration of the atomic model Rutherford developed after his gold foil experiment. The illustration should include several electrons and a nucleus. Alright, so you can hit pause and do that. Identify relevant information. Rutherford's gold foil experiment proved that the atom has a dense, positively charged center. The center is called the nucleus, and it's positively charged. The negatively charged electrons are located outside the nucleus. Rutherford's original model did not include the protons and neutrons as individual particles, because they didn't know that yet. The drawing should have a small region in the middle for the positively charged nucleus. If you drew the protons and neutrons in the middle, that's fine. This is not a huge deal. His big contribution was that the nucleus was the positive portion in the center. The electrons were around it. Describe Rutherford's gold foil experiment. Summarize the setup and results of Rutherford's gold foil experiment and explain how those results led Rutherford to formulate a new model of the atom. So recall relevant information. Rutherford's experiment involved a sheet of very thin gold foil and a stream of positively charged particles and a detector that glowed when it was hit by those positively charged particles. So most of them went straight through, some of them bounced a little off to the side, and some of them bounced even straight back this way. Rutherford fired a stream of positively charged particles at a piece of thin gold foil surrounded by a detector and we'll talk about the rest of this paragraph in the next video.